Welcome to my channel. My name is Casey Charnomsky, and we're here discussing technological advancements now, the near future, the far future, and these advancements are ranging all over the board from biotech to nanotech, artificial intelligence and robotics, additive manufacturing. All these industries are going to be revolutionizing at exponential rates, and they are right now, and they're going to be affecting all of us on a day-to-day on our day-to-day lives. We're here to talk about it. We're here to talk about how they're affecting us individually and how they're going to affect the whole world once these things are out and released into the public and for people to be able to use. Welcome to the channel, and I'm looking forward to these discussions with you.
I would also be thrilled if more of you experienced physicists out there, uh, more of you math geniuses, if this sparks an idea in your head or if it seems to be clicking to you, I'd love for you guys to try and jump ahead of me here or throw any ideas or suggestions back my way.
Well, I'm not an experienced physicist or a math genius, but I do have a couple of ideas that I would like to throw your way. And I think that after watching your video and all the work that you've put into it, scrolling down here and looking through the timestamps and all the different topics, uh, the amount of work that you and your daughter did and the quality of the video is great. I think everybody should go check it out. Chris the Brain, I think you and your daughter did great. Your topics are really interesting, and your extra dimensions approach is very intriguing. And I feel like there's a study that came out recently that could really add to a little bit of context and maybe, a little bit add to the conversation. So everyone, please go check out his site. It's his page, his videos. Um, this one's done really well. It's great. It's really got great humor, and so I highly recommend checking it out. I'll provide the link in my information below. Now let's get on with the conversation. Welcome everybody. I figured that I would start by addressing the monster in the room. I believe in physics, the monster in the room is gravity. And I think that a lot of this topic will be discussing how gravity and quantum mechanics and extra dimensions of space affect our reality. So today I'm going to go over an article that I read back in December of last year and I found very interesting, and it's taken me a little bit of time to digest it and go over other concepts around it. And so this is what I have come up with. The title of the article is Three Dimensions, One Space Dimension, Relativity of Superluminal Observers in 1 plus 3 Spacetime. The article is written by the University of Warsaw, and it was published on physics.org. I'll provide a link in the description below. I believe that this article has a lot of input that describes very closely what we are having problems with in quantum mechanics and gravity. And I believe that they are on the right path to figuring this out. Um, so, without further ado, let's dive down this rabbit hole. First, I want to go over this article, which came out December 22nd of 2022 by the University of Warsaw. Its title is Three Time Dimensions, One Space Dimension, Relativity of Superluminal Observers in 1 plus 3 Space-Time. How would our world be viewed by observers moving faster than light in a vacuum? Such a picture would be clearly different from what we encounter every day. We should expect to see not only phenomena that happen spontaneously without a deterministic cause, but also particles traveling simultaneously among multiple paths, argue theorists from universities in Warsaw and Oxford. Also, the very concept of time would be completely transformed. A superluminal world would have to be characterized with three time dimensions and one spatial dimension, and would have to be described in the familiar language of field theory. It turns out that the presence of such superluminal observers does not lead to anything logically inconsistent. Moreover, it is quite possible that superluminal objects really exist. It goes on to talk about Albert Einstein, three-dimensional space, fourth-dimensional time. I'm not going to read the whole article. If you like, I can. I will post the link to it in my comments below, and you can feel free to check it out for yourself. Einstein bases theory on special relativity on two assumptions: Galileo's principle of relativity and the consistency at the speed of light. Typically, the principle applies to observers who are moving relative to each other at speeds less than the speed of light. However, there is no fundamental reason why observers moving in relation to the described physical systems with speeds greater than the speed of light should not be subject to it, argues Dragon. What happens when we assume, at least theoretically, that the world could be observable from superluminal frames of reference? There is a chance that this would allow the incorporation of the basic principles of quantum mechanics into the special theory of relativity. This revolutionary hypothesis of professional Andrzej Dragon and Professor Arthur Eckert from the University of Oxford presented for the first time in the article Quantum Principle of Relativity, published 2 years ago in the New Journal of Physics. And this is the key. This is what's really important here. There, they considered the simplified case of both families of observers in a spacetime consisting of two dimensions, one spatial and one time. In their latest publication of the journal Classical and Quantum Gravity, titled The Relativity of Superluminal Observers in 1 plus 3 Spacetime, a group of 5 physicists goes a step further, presenting conclusions about the full 4-dimensional spacetime. The authors start from the concept of spacetime corresponding to our physical reality, with 3 spatial dimensions and 1 time dimension. However, from the point of view of the superluminal observer, only 1 dimension of this world retains a spatial character, the one along which the particles can move. The other 3 dimensions are time dimensions. From the point of view of such an observer, the particle ages independently in each of the 3 times. But from our perspective, illuminated bread eaters, it looks like a simultaneous movement in all directions of space, i.e., the propagation of a quantum mechanical spherical wave associated with a particle. Commented by the professor. Professor, I'm not going to pronounce that right. Just read it and do your best. It is, as explained, in accordance with the Huygens principle formulated in the 18th century, according to which every point reached by a wave becomes the source of a new spherical wave. This principle initially applied only to the light wave, but quantum mechanics extended this principle to all other forms of matter. Now, this is really important, so I'm going to repeat it. The principle initially applied only to light waves, but quantum mechanics extended this principle to all other forms of matter. The new definition preserves Einstein's postulate of consistency of the speed of light in a vacuum, even for superluminal observers, prove the authors of the paper. Therefore, our extended special relativity does not seem like a particularly extravagant idea. For a superluminal observer, the classical Newtonian point particle ceases to make sense, and the field becomes the only quantity that can be used to describe the physical world, notes Andrzej Dragon. Until recently, it was generally believed that postulates underlying quantum theory are fundamental and cannot be derived from anything more basic. In this work, we show that the justification of quantum theory using extended relativity can be naturally generalized to a 1 plus 3 spacetime, and such an extension leads to conclusions postulated by quantum field theory, write the authors of the publication. All particles therefore seem to have extraordinary properties in the extended special relativity. Does it work the other way around? Well, it's not that simple, says Professor Krzysztof Brzezinski. I'm guessing. The mere, I should know this stuff because I'm half Polish. The mere experimental discovery of a new fundamental particle is a feat worthy of the Nobel Prize and feasible in large research team using the latest experimental techniques. However, we hope to apply our results to better understanding the phenomenon of spontaneous symmetry breaking associated with the mass of the Higgs particle and the other particles in the Standard Model, especially in the early universe. So what he's basically saying is that's not what they were intending to do with this process, but it seems like it might apply. Now, symmetry breaking is a tachyonic field, and it seems that superluminal phenomena may play a key role in this Higgs mechanism. And this is what is the catch here, because we haven't been able to prove tachyon fields exist. Now, that's something that we're trying to figure out scientifically in the realm of detecting and being able to figure out if it is detectable. Now, this is another key part of this article, and I'll reference the study in a moment. It seems the superluminal phenomena may play a key role in the Higgs mechanism, and any spontaneous symmetry breaking mechanism is a tachyonic field. It's the crucial ingredient of any spontaneous symmetry breaking mechanism. Now, going over to the study. This is the study. I'll provide the access to it. I'll provide the link to it in my description. Relativity of superluminal observers in 1+3 space-time. We develop an extension of special relativity in 1+3 dimensional spacetime to account for superluminal inertial observers and show that such an extension rules out the conventional dynamics of mechanical point-like particles and forces one to use a field theoretic framework. Therefore, we show that field theory can be viewed as a direct consequence of extended special relativity. Now, I'm not going to go through and read this whole paper. It is semi-long, and there is a decent amount of equations, as you can see, although they are not equations that are unreadable. I have a basic understanding of calculus, and I can understand the majority of what this is as far as what it's trying to accomplish. But I don't know the detail. I can just follow the basic equation to read the equation. Um, Now, down here at the bottom, at the conclusion, at the very end of the conclusion right here, a relevant question that remains to be answered is whether tachyons, understood as localized lumps of energy traveling with superluminal speeds, can physically exist. As was shown here and earlier in, special relativity does not exclude such a possibility. In quantum field theory, mechanisms of spontaneous symmetry breaking, such as the Higgs mechanism, involve fields whose mass squared is negative in the unbroken phase, so excitations of those fields can be regarded as tachyons. In the phase with the broken symmetry, those fields are expanded around a degenerate local minimum, so their excitations have positive mass squared and are known as Higgs particle behaving as regular subluminal particles. However, the basic principles of the mechanism always involves tachyons as a starting point. Given rather interesting kinematics and dynamics of superluminal particles discussed in this work, it would be interesting to explore the initial phase before symmetry breaking in more detail and the role of tachyons therein. We believe our current work should stimulate new research in this direction. Now we're talking about superluminal space, viewing things from a superluminal point of view. And so, in order to get an idea of what this is all about and how to view this, I brought up a really interesting article here. And this one is Quantized Columns, The Journey to Define Dimension. It is written by David S. Richardson, and I'll also provide a link for this article below. I will not be reading this article as well. I'm just using it as a reference point. The Journey to Define Dimension. So, in the video that I showed at the beginning, the clip, in that video, Chris talks about the different objects falling through a two-dimensional space and traveling along a two-dimensional space. And in this case, I'm going to bring up this reference right here, which shows a three-dimensional object falling through a two-dimensional plane, and the two-dimensional plane observes only what is this darkened area in the middle. They don't see any of the rest of the object. They only observe this part as it passes through. Now, the really interesting thing is that there is a there is a way to be able to kind of view this in a higher dimension. Now, what I'm showing is this is basically showing cubes, tesseracts, 0, 1, 0, 1, 2 dimensions, 3 dimension being the cube, 4 dimension is the cube or a tesseract traveling through time. Be that as it's either growing bigger or getting smaller, because the glass tesseract, which is shown in multiple video settings, it has a small cube inside of a larger cube, and it's the fourth dimension is the movement from that smaller cube to the larger cube. It's not the three-dimensional object itself. And so the basic understanding of dimensionality is right here: 0, 1, 2, 3, 4 dimensions, the fourth one being time added onto the 3 dimensions of space. But what's really interesting is what we are seeing here is an example of three-dimensional space or four-dimensional space and time with an added fifth dimension. The fifth dimension is passing through our three-dimensional, four-dimensional space-time, and it's and this is a visual example of uh, what's going on in the fifth dimension all around us. All right, now coming back up to a point that I read a little bit ago, this is what really stuck out to me. These two paragraphs right here. The other three dimensions are time dimensions. From the point of view of such an observer, the particle ages independently in each of the three times. But from our perspective, the illuminated bread ears, it looks like a simultaneous movement in all directions of space, i.e., the propagation of a quantum mechanical spherical wave associated with a particle. It is, as explained by Professor Andrzej Dragan, in accordance with the Huygens principle formulated in the 18th century, according to which every point reached by a wave becomes the source of a new spherical wave. This particle initially applied only to the light wave, but quantum principle. This principle initially applied only to the light wave, but quantum mechanics extended the principle to all other forms of matter. That is the definition of gravity right there. A simultaneous movement in all directions of space. Kind of like here on Earth. We experience gravity and the simultaneous motion, the feeling of Earth pushing up on us, not us falling onto the Earth. So this right here explains gravity in a quantum mechanical state very clearly. And there is a lot of reason to want to explore what this means and what being a superluminal observer would mean according to the physics. Thank you all for liking and subscribing if you've done so, and all those who tuned in otherwise as well. I'm trying to bring up the things that I find interesting in today's news, and if you like it, please feel free to share with your friends.